All right, so the next set of basic identities I want to introduce to you is what we call Pythagorean identities, and there's three different forms here. One has to do with the sine and cosines, one has to do with tan and secant, and the other being a cotan and cosecant. So once again, you don't have to memorize these again because you do have them on your formula sheet. I do want to explain though why they're called Pythagorean identities, because each one does follow a pattern you might have seen before, which is called Pythagorean identity or Pythagorean theorem. Okay, so each of them follows that same type of pattern. It's definitely evident in the first one. So using these three identities, I'm going to go ahead and prove the first one here. So once again, when you're proving an identity, you want to prove that left-hand side is equal to right-hand side. So, just like in the other previous podcasts, you want to try to rewrite everything in terms of a primary ratio, so sine, cosine, or tan. So as you can see here, each ratio that you see up here is already primary. But however, we can rewrite tan theta in a different form using, of course, our reciprocal or our quotient identities from before. So what I have here is sine theta plus cosine theta all over. So instead of tan theta, I'm going to go ahead and replace that with the sine theta over cosine theta. So once again, that is your quotient identity. This is all equal to 1 over cosine theta times the tan theta, which is once again sine theta over cosine theta. So as you can see here on the right hand side, we do have something in common here. Cosine theta and cosine theta, those do cancel out. So what I end up having on the right hand side here is 1 over sine theta. So that's as simplified as we can go there. So the manipulation needs to happen on the left hand side here. So the manipulation that needs to happen here is has to do with this second term here. We do have to divide by a fraction. So to divide by a fraction is the same thing as multiplying by its reciprocal. So I'm going to take the top, which is cosine theta, and multiply by the reciprocal of the bottom, and that is cosine theta over sine theta. So you just want to go ahead and flip that fraction there. So just to clean this up a little bit, sine theta plus cosine theta times cosine theta is cosine squared theta over sine theta. And this should be equal to 1 over sine theta. Okay, so as you can see here on the left-hand side, we still have some more simplification to go. Let's combine these into one fraction here because we do want to simplify. To simplify here, take the first fraction, multiply the top and the bottom by sine theta to create the same denominator here. So what you're left with here is sine squared theta over sine theta plus cosine squared theta over sine theta. And this should be equal to 1 over sine theta. So once again, we have the same denominator, so go ahead and add the numerator. So I get sine squared theta plus cos squared theta all over sine theta. Okay, and this should be equal to sine theta. Now, it may not look like it at first, but notice that the top, both these terms are squared. So you could apply a Pythagorean identity. So let's see which identity we can use up here. So I'm just going to go ahead and bring this down. So we have sine squared plus cos squared on the top. As you can see here, that is an identity. It's the first one here. So the top is essentially equal to just 1. So I get 1 over sine theta, and that does equal the right-hand side. So I believe I just completed the proof.